Good morning. I'm giving the talk today, but I should start by giving a big shout out to Lindsay Fox and Marina Rillo. Lindsay was a postdoctoral worker at the Natural History Museum, and Marina was a PhD student. They carried out the two case studies which I'm going to highlight during my talk today. So first of all, I'm going to start by looking at the ocean bottom sediments collection, give you a few details about that. Secondly, to go on and look at some of the historical issues with working with some of these sediments. And thirdly, to look at the Challenger Revisited project. And finally, to say a few words about collections advocacy. The Ocean Bottom Deposits collection consists of about 40,000 oceanic samples from locations worldwide, roughly 45% from the Atlantic, 35% from the Pacific, and 20% from the Indian Ocean. I've included the image above because it's one of my favourite images of collections. As a micropaleontologist, this sample here contains is almost exclusively planktonic foraminifera, a calcifying planktonic organism which lives in the oceans today. The core of the ocean bottom deposit collection is the Challenger collection, which came as part of John Murray's collection in 1921. The museum also holds other Challenger materials, including fish, mollusks, ostracods, foraminifera, bryozoans, echinoderms, and corals. As well as the Challenger collection, there are various other historical sediment collections, perhaps the most famous one being the Terra Nova collections from Scott's ill-fated Antarctic expedition. The ocean bottom deposits collection has not been used a huge amount over the last 20 years or so. One of the main reasons for this is the methods of collecting of the sediments. On the right hand side here is an example from the Challenger report showing the dredging mechanism which was crudely drawn along behind the Challenger ship. This dredging could potentially be sampling layers which go down to perhaps represent sediments deposited 10, 20 or even 30,000 years ago, depending on the speed of deposition of the sediments. Also, these collections sometimes, although the Challenger collection, it must be said, has got meticulous information with it, sometimes the sediments have been processed after that, and some of these details may be missing from the records associated with those collections. This is where Marina Rillo's PhD program came in. Marina was studying at Henry Buckley's collection. Henry Buckley was a former curator in the mineralogy department responsible for the ocean bottom sediments collection, but he also had an interest in the planktonic foraminifera. In fact, he was one of the first people to use a scanning electron microscope to study wall structures. So Marina, as part of her project, digitized Henry Buckley's slide collection and was looking to use information from that collection to answer information about plankton evolution. So this is an example of some of the sediments that are in the Buckley collection. What Marina did was she zoomed in on 10 samples from that collection, covering most of the oceanic basins. And she was looking to look at, she went back to the collections in the ocean bottom sediment collection and reprocessed them and found out her own information from those samples to look to see whether there are any biases in Henry Buckley's collection. And the main conclusion to that was actually Buckley did a pretty good job. He may have used slightly larger specimens, but he picked out all the key taxa in those samples. What Marina also did was to use global reference data sets to compare her data with, first of all, data sets for the Holocene, which represent roughly the last 11,700 years, and finally, data sets from ocean drilling cores, which represent the last glacial maximum. This graph here, this illustration shows a statistical analysis, first of all comparing the historical and the Holocene, secondly the historical and the last glacial maximum, and finally the last glacial maximum and the Holocene. Any of the bars which appear towards the top of the line of the graph here show an enormous similarity between those collections. So you can see if the three of them are all very similar, it's very difficult to piece together whether you are sampling from information possibly from the last glacial maximum. But if they're quite different, then it's much easier by looking at the assemblages of planktonic foraminifera within those samples to see whether we may have time averaging covering large periods of time by dredging some of these samples. So Marina's conclusions were mainly that Buckley did a good job, and these slides in the collection are really useful and can be used by scientists to make inferences. Mainly that the climate-sensitive microfossils can be used to assess sediments that may contain a mixture of modern and glacial sediments. And that also that potentially this means that we can use these samples to benchmark the state of marine ecosystems in the late 19th century. And really key to collections is that these can be used as a historical baseline to assess trends in the evolution of the ocean. The second case study was carried out by Lindsay Fox, who was also looking at challenger materials, but this time instead of using material dredged from the bottom of the ocean, she was able to identify some plankton tow material collected by the challenger. So this would have represented information from collections which were present in the water column at that particular time in the 1870s. And she was able to also obtain some material from the Tara expeditions, which covered and carried out plankton tow collections in the same area almost 150 years later. So what Lindsay did was to CT scan a number of specimens from the collections and compare the shell thicknesses in some of those collections with those from the Tara. And you can see in this slide here at the bottom, these represent the challenger collections. And you can see the shells are much thicker, and the ones at the top represent the Tara expedition specimens. And for all of the specimens she scanned, all of the modern ones were significantly thinner than the historical plankton tow material collections. And the conclusion that she came to was that this was due to acidification of the oceans since the time of the Challenger expedition. And so her conclusions were that in fact that some of them were up to 76% thinner, but all of them were thinner, and that the variations also there were variations in calcification between different taxa that live in different parts of the thermocline, which is what you would probably expect. But the key thing is that highlights the potential of these historical ocean plankton collections to show effects of anthropogenic processes such as ocean acidification. So in terms of collections advocacy, clearly publishing conclusions like this in very high profile journals is a key way of getting information out there and about the potential for these museum collections and for other workers to work on them. And you can see here that the stories from this publication were picked up by, this is the Altimetrics score for that particular paper. A huge number of tweeters tweeted about it. There was also a lot of coverage. The 6 blogs mentioned there include some newspapers which covered the article. And in the year, in 2020, it was one of the top referenced downloaded articles for in Nature Communications. But there are other ways of advocating for those collections and making them more widely available. The NHM data portal, all of the materials that have been involved in these projects and all of the ocean bottom sediment collections are digitized and are available on these portals. However, the portals are rather geared towards collections which have some sort of identification attached to them. So this is something we're working with the portal people at the Natural History Museum to perhaps find ways of advertising these sample-based collections in a more efficient way. Everything also that goes to the Natural History Museum portal, if it has a binomial identification, goes out to the GBIF information facility. But again, because there's no binomial information with these collections, they don't tend to make it as far as this data set. And it may be that people looking for this type of material may not start to look in this particular area. And here's an example of perhaps a more targeted approach towards advocating for these collections. As a project we were involved with that people at NatSCA have heard about. A project we were involved with RAM a few years ago, and this collection website is still up and available and gives a wide variety of Challenger collections information. Mentioned blogs. We also blog at the Natural History Museum, and it's an important way of raising the profile of information about our collections and work which goes on with those collections. But finally, I wanted to end, and I don't want this to come across as being critical of my institution, but we did engage with, this is an exhibition which will be open by the time this talk is aired, but this is an exhibition on Our Broken Planet, and we had discussions with the museum about including information about these projects, about the ocean sediments and what they can tell us about the Anthropocene and particular man's effect on the oceans. However, it wasn't included in either this or in the Channel 5 documentary, who we also spoke to. But rather than being bitter about this, I think this is a really important message, a take-home message, that as custodians of these collections, it's really important that when we do have these good stories, that we continue to keep telling them, and we continue to keep making the profile of our collections and the work and the information which comes from work and research on our collections known to the outside world. So finally, just with a few conclusions, these sediments, the historical sediments in the Challenger and the ocean bottom deposits, really can be used as a benchmark as the state of the marine ecosystems in the late 19th century. And these historical sediments can be used to assess global change trends and to indicate information about things such as ocean acidification. And finally, as I said just now, advocate. When we've got stories like this, keep telling them and keep making the information about your collections available to as many people as you possibly can. Thank you.
Giles, that was a really fascinating talk. Thank you so much for sharing with us. I had no idea that that was a way to assess acidification of the oceans. So yeah, really awesome. Thank you. I just had one question, which might sound really naive because this is something that I don't know much about, but can living or recently deceased plankton be scanned in the same ways? So are you looking at the thickness of their skin?
Yes, very much so. I mean, the Challenger Revisited project was very much a case study designed so that we can carry on and perhaps do other studies. One possibility is to look at things like discovery plankton collections and other plankton collections which are available in museum collections.
Are you talking about in the
yes,
UK,
very much
or
so.
is this around the world?
Yeah, anywhere around the world. I mean, ideally, I mean, the example we had was from the Pacific. Ideally, we'd like to look at this across all the different ocean basins. And certainly there are collections available in museums that could help us to do this.
Awesome, thank you. Are there any other questions? Well, if anyone thinks of anything else they'd like to ask, please stay with us at the end of this session. There'll be a quick Q&A. Thank you, Giles.
Thank you.